Hi everyone, my name is Chris Helm, and this is a video tutorial which is going to cover a lot of the basics of working with Unity's NavMesh system and some introduction to AI scripting in Unity. Now, Unity doesn't really have a lot of tools that are geared specifically towards AI. The NavMesh system is probably the closest. It's going to see the most use with AI. It can be used for character movement if the character needs automatic movement for like a point and click movement. But AI is where it's going to see the most use. So to start, we need to open up the navigation window. To do that, we click on the window up here, come down here, click on navigation, and then right next to the inspector, where the inspector tab is, you'll get another tab that pops up that says navigation. Now we have some options here. What the NavMesh is it is a flat plane that represents the traversable area in the game. Now, the plane doesn't have to be horizontal. If you have ramps or if you're dealing with terrain, there will be planes that are sloped. But the important part is that it's the flat area that the objects can traverse. So you have a couple of options for calculating the level geometry. You can select all, which will go through everything in the scene, gather up all of the geometry in the level, and then calculate all of the traversable areas and bake it into the scene. If you have a complex scene, and this scene isn't really complex, but if you do have a complex scene with, say, doors that open and close, or areas that are only traversable sometimes, the mesh renderers is the much better option, which lets you select the specific geometry in the scene that you want to be included in the NavMesh calculations. And then also, if you are building a game that utilizes terrains, which we're not using here, you can select the terrains right there. So we're going to select mesh renderers. I have a player character right here that'll be used later in demonstrations, and that won't actually affect the NavMesh, but so you guys can see how this works. So I'm going to select everything except for the player geometry. And as soon as I do that, a couple of other options crop up: navigation static and generate off-mesh links. And I will explain what off-mesh links are shortly. For now, I'm going to leave it clicked on. And we're going to come over here to the bake options. Now, the bake options are used as part of the calculations for determining the area that can be traversed. The most important ones are these top four right here. Now, the agent radius, I'll talk about NavMeshAgents after we finish up with the navigation mesh. But the NavMesh agent is what is the component that actually reads the NavMesh and calculates paths to various points. And it has a specific radius. So this will affect how close to the edges of the geometry the objects can get. Now, if you have an area, if you have a scene that has multiple levels that the player can get to, or maybe it doesn't have multiple levels, maybe it just has a ceiling, the NavMesh height comes into play, and that represents the height of the character. That is the minimum height between the level you're currently on and the next level up that the player will or that the object will fit into. So if you have like an overhang that hangs down too low for the player to fit there, the area underneath that overhang will not be traversable. Now if you have ramps in the level, the max slope comes into play. As the lineup just to the right of the blue cylinder, if you watch, if we drag that down, this represents the maximum slope that the NavMesh agent, the object the NavMesh agent is attached to, can traverse. We can set it all the way up to 60, or we can set it down to 0. And then the step height, if you have steps, stairs for example, or just areas where there's a slight difference in elevation between two different pieces of geometry, like a sidewalk that's next to the street, step height will affect that. That will affect areas that can be traversed to. So if we come down here to the generated off-mesh links, now before we get to this, I'm just going to go ahead and bake this in here. To start with, I'm going to set this to 2 so I can show you guys the difference between, so I can show you guys how agent radius affects the NavMesh. So if we click bake, and make sure that down in the bottom right corner of your scene tab, you have show NavMesh clicked. If I deselect it, it doesn't show up anymore. So we'll just reselect it. Now the blue area right here is the NavMesh. This shows the traversable areas based on agent radius, based on all of these values right here. So if we make this smaller, we'll take it back down to what it originally was, to 0.25, and we will rebake it. Now we can see that the traversable area is much closer to the level geometry. And also some areas that previously weren't included in NavMesh are now included. You can see the tops of all of these obstacles right here are included. So now that we have our NavMesh, our initial NavMesh built, we can talk about off-mesh links. So if you take a look at the scene right here, in the center we have these two big cubes, and each of them has a NavMesh area on the top. So if we clear this and come back over here to Object and we deselect Generate Off-Mesh Links and we rebake it, you can see that there's a NavMesh on the top of each one of the obstacles here, but there's no way to get on top of them. So if we reselect Generate Off-Mesh Links and we rebake it into the scene, and on a side note, it's really important, if you change any of the level geometry in, and it will affect the traversable area, you have to rebake the NavMesh into the scene. So back to the off-mesh links, you'll notice that there are now a bunch of circles with arrows that connect a bunch of them together. Now those are off-mesh, that's what's called an off-mesh link. What that represents is a point where the NavMesh agent can traverse between NavMeshes that aren't connected. And I will show you how that works. Click on that. We're going to drag an AI in here. So now if we come over here and we click on play, this is currently this is just a really simple follow script for the AI. But you can see if I drag this object that it's supposed to follow, it can move between the nav meshes. Just like so. And the way that works is you have an option under the NavMesh agent, under the pathfinding part, it says auto traverse off mesh links. If that's selected, that will automatically it will automatically move between off mesh links if the shortest distance, if that leads to a more intelligent path. So I'm not going to really talk about the advanced stuff. That isn't really going to come into play. The last thing I want to mention about the NavMesh is these areas. So we have areas, they're basically layers, where you can set exactly what the layer is, and you can give it a cost. And what that allows you to do is it allows the object to more intelligently pick its path. If, say for example, you have a river passing through in your level, and you have open terrain on both sides, and there's a bridge. Now, if you have an off-mesh link so that the player can jump across it, or you can give the jump a specific cost, and when the NavMesh agent calculates a path to the other side, it will take that into account. If the bridge happens to be cheaper, then it will more than likely take the bridge. Another option is you could create a water layer, like so, and then you can come over, you can get a cost of, say, 3, if the objects can swim. And then you can make the entire river, set the entire river to the water layer, and when it comes time for that object to cross the river, it will determine whether or not it's faster or more intelligent to swim across, or to walk a little bit further and take the bridge across. So that pretty much sums things up for the off-mesh links. I'm going to adjust this real quick. And now we can talk about the actual NavMesh agent. So we'll drag this AI over here, come over here to the inspector. Now if you need to add a NavMesh agent, I just prefer to do the search. If you type in nav, it'll be the first one that pops up. I've already added one, so we can come up here. There are a bunch of values in here. So if we come down here to the AI, which is right here, you can see the cylinder collider around the AI. That represents the diameter of the NavMesh agent, and you can adjust that up or down. So if we set that up to 1, you can see that it gets bigger. We'll set it back down to 0.5. You should, when setting your radius and your height, you should try to match the size of the object it's attached to. And then we have the base height offset. Generally, it's going to be 1/2 of the height. That way this collider right here will sit on the ground level. If now we come down here to steering, we have a couple of variables. We have the speed variable. That specifically affects how fast the maximum speed that the object can move at. The acceleration is pretty self-explanatory. That's how quickly the object will accelerate to max speed. Stopping distance, if you have like driving, stopping distance would come into play. That's the distance that that's required for it to come to a stop. And then we have this auto braking right here. This is really important. If you are developing an AI that is supposed to patrol an area and you want your movement to be really smooth, you're going to want to make sure this is not checked. When you tell the NavMesh agent to go to a specific point, if auto braking is selected, your AI object will automatically stop when it gets to that point. So if you want smooth movement, you're going to want to turn auto braking off so it doesn't stop when it reaches the end of the path. Now, obstacle avoidance, this is just collision detection. Obviously, the lower the quality, the lower quality is going to improve performance, whereas high quality is going to give you better collision avoidance. And then pathfinding, I've already mentioned the auto traverse off mesh links. If you can determine whether you want that automatically on, whether you want it to do that or not. The auto repath comes into play if something gets in the way of, if something interrupts the path, the chosen path. Selecting this will cause a new path to automatically be generated that will avoid the obstacle that is in the way. And then the area mask determines what areas the game object can traverse. So you can set it to, we could set it to nothing and then it can't do anything. We could set it to walkable only. We're just going to go ahead and leave it selected at everything. And that is all of the basics to working with the NavMesh and the NavMesh agent. So let's go ahead and move over to the scripting aspect, to the coding. So for coding, there's a couple of really important things that you need. You need a world interface, a collection of data that the AI is going to use to make decisions. You're going to have a set of data specifically related to the AI, and then you're going to have some behaviors and some method of determining which behaviors to determining what to do. So for this, I've divided everything up. The AI world interface is really simple. The really simple AI that I've created will act as the foundation for some squad-based AI that could accompany the player along as they go through the game. So for now, if we look in the level, we have 9 of these obstacles in here, which represent cover positions, where the AI can hide behind if they were to take enemy fire. So since we don't have any enemies in the game, currently that's the only thing that we need to access is the covered locations. And then we have some basic data about the cover locations. Now, when it comes to the actual AI, I've split everything up across several scripts. First, we have the AI data script. Now, this contains all of the variables, all of the universal variables that need to be accessed by all of the other AI functionality. So you can see we have a behavior, an enum behavior, as well as 2 instances of it, behavior and last behavior. We have a delegate. For anybody that doesn't know, delegates are basically function pointers, with the added benefit that they can point to multiple functions simultaneously. I'm really not going to get into that in this project, but it is something to keep in mind that you can assign multiple functions to a single delegate, and when the delegate is called, it will call all of the functions. The big ones that we have right here are the NavMesh agent, a reference to the AI's transform, and a reference to the transform that it is going to follow. And then we have a minimum movement cushion and a maximum movement cushion. I'm not using the minimum movement cushion yet, but in the future I will. For now, we're just using the maximum movement cushion. And then in the start function, we initialize all of the behavior, all of the variables that need to be initialized. So if we come over here, we have our default decision tree. I'll scroll up to the top. For anybody that isn't aware, Unity has this bracket syntax right here, where you can make statements. For the one that I'm using right here is require component type of AI data. So if we come back over here and we remove the decision tree and we remove the data script, we come back over here to scripts. If we grab this default decision tree right here and drag it onto the AI, it automatically adds the data script. And now if we try to remove the data script, we can't, because the decision tree relies on it being there. There are a whole bunch of other commands that you can check out on Unity's website. Now for the decision tree, I have some references right here to other scripts. And I will explain these other scripts for shortly after I get done with this one. But we have a reference to the AI's data script, which I just went over. And we also have reference to the follow script, the hold position script, and the take cover script. And then in the start function, I've I run a check on the game object to see if it already has the follow script, hold script, and cover script, and if not, it will automatically add those. If you get into a situation where you have multiple decision trees, this can come in handy for removing behavior scripts that you don't necessarily want or need. And then we assign the references down here, and then we call the appropriate, and then we're going to set our state in the following switch statement based on the initial behavior. Now, this right here, under the update function, this is all of the code that's required to run the AI consistently. Up here, we have a single, since we don't have enemies, and we don't have a lot of player mechanics to direct our squad mates. The decision tree right now is really, really simple. All we're doing is we're checking to see if the behavior from the last frame is still the same, if the behavior from this frame is the same as the behavior from the last frame. And if it's not, then we are going to change, we're going to take the state that it's in, and we're going to change to a different finite state machine in the appropriate script. And then we're going to come down here and we are going to call onBehaviorEnd, so we can, if there's anything that needs to happen now that we're not using the previous finite state machine, it will tie up any loose ends. And then the last thing we're going to do is we are going to call the actual, we're going to have it run the functionality that it's supposed to be running for this frame, and then we're going to set last behavior equal to the current behavior. That way this block of code up here will not run again. So if we come over here, this is the entire follow script. We've made a reference to the data script, so we can gain access to the NavMesh agent. And then we have a single timer and a couple of values right here, so we don't have any magic numbers. The path update delay, we could make that public if we wanted to, so we could adjust it in the inspector. What the path update delay does is, while the AI is following the player around, this is the frequency with which it will update the path. And then this minimum distance to point is used to determine whether or not the AI has arrived at its destination or not. So in the start function, the only thing we're doing is we are initializing the reference to the data script. And then this onBehavior start function, which every finite state machine has, this carries out the initial, this initializes the state so it can start carrying out the behavior. The vector3.square magnitude, that calculates a square distance of a single vector. You'll notice that I have it's the object it's following, that position, minus the current position, which will give us a vector that has some magnitude to it. So it will take the square of that and compare it to the square of the maximum move cushion. And if it's greater than that, then we are going to come down here and we are going to tell the NavMesh agent, we're going to have it set the destination to the follow position object. Then we're going to initialize our path update timer to 0, and we're going to set our state to follow. Now if we're already, now if if the square distance between the object we're following and our current position is less than the square of the maximum move cushion, we're going to go straight into idle. Now, once we get into the follow, we're going to increment the path update timer by time.delta time every frame. And then if we've arrived at our location, this next line of code determines the square distance between the object we're following's position and our current position. And if that is less than the square of the minimum distance to point, we're going to transition to idle, so the AI will stand still. If that's not the case and enough time has passed, then we're going to update our destination and we're going to reset our timer back down to 0. The only other state that we have is the idle state, and this just tracks the maximum, the distance between us and the object we're following, and if it's greater than the maximum move cushion, then we're going to move back to the follow state and start moving again. Now, if we come over here to the AI hold, this behavior just tells the AI to stand in place and not to do anything. So there's really not a whole lot there. Now, the cover is where things get slightly more complex. The first thing that we have to do when we look for cover is we have to access the world interface, and we have to find the closest cover position that's not occupied, and then we're going to set a path to that. We're going to set the occupied variable for the cover geometry to true, and then we are going to move to that position. Now, once we've arrived at the position, which is this next function right here, once we've arrived at that position, we're going to transition to idle. And then every 1 second while we're idle, we're going to determine what the closest cover position to the position we're supposed to be following is. And if it's different than the position that we are at, we're going to move to that next position. Now, to do that, you'll notice there's the code is really, really simple through this. And that's because if we come over here to the AI helper functions, I've started a list of static functions that can be accessed by anything to carry out all of the heavy lifting. So under the public static, under this get closest cover position, we are going to create a list that has all of the unoccupied cover positions. We're going to feed that into an array, and then we're going to sort it so that the cover position that is closest to us is first in the array, and then we are going to return that. So if we come back over here, we already have we'll come back over here to prefabs. So if we drag our two AIs over here, the last thing I did was I created a really simple GUI so we can control which state we can emulate player commands to control the states of the AIs. We'll go ahead and link up some variables here. So if we press play here, the default state is going to be follow. So I can move around the level and you can see that both AIs are going to follow me around. So if I click on this stay right here, you can see that the blue AI is no longer going to follow me around at all. He's just going to stay in place. And if we come down here, I can click on take cover, and you can see that the red AI is now going to hide behind one of these obstacles. And then, like I mentioned before, every second it is going to check to determine whether or not there is a closer cover position. Now, just to provide a little bit more clarification, each one of these scripts over here, now that you saw the way the AI works, each one of these scripts is an individual finite state machine. Under the cover, if you look, under this if block right here, this data.state, the first thing that we do when we switch to cover is we set it to on behavior start. And then from there, you can see that we set the state to move to new position. Once the state is set to move to new position, in the update function in the default decision tree, that state functionality is called every frame. So if we come back over here, once the condition, once it has reached the position it's trying to go to, it will then transition to idle, and then it will transition between move to new position and idle until we decide that we want to use a different finite state machine. And follow works the same way. In the on behavior start, we're either going to start off following or we're going to start off idling, and then we are going to move between the two depending on the situation in the game. So while this may seem really complex at first because the code is split across so many different scripts, it's actually far easier to maintain. And later on, when we add other behaviors, such as the ability to shoot, we'll see that we can run multiple finite state machines at the same time by using these delegates without having to program a lot of complex transitions. So that about wraps it up. Thanks for watching, and I hope you guys learned something.